now let's start with the first topic of this chapter, central tendency. So what is central tendency? It is basically there are certain metrics or certain parameters that are defined for us to understand a given data set very easily. For example, there must be a long data set given to you of maybe 1000 entries or maybe 2000 lakhs, crores entries. So there are majorly three metrics through which we can understand what exactly the data set is all about, and they are mean, median and mode. So these three are basically the statistical metrics that describe how central tendency of a data set would look like. So I'll show you this with the help of a graph. Let's say this is our graph and this goes up till infinity. Here we have our class and here we have frequency. So generally, whenever you are given a data set which is related to statistics, it is represented by these two parameters, where x-axis is represented as class and the y-axis is represented as frequency. So here this is a very huge data set. Now we know the data is going up till infinity. So there are three parameters, again mean, median and mode, through which we can understand what this data set exactly is all about. So measures of central tendency means these three metrics would lie somewhere around the center of this graph or this data set. For example, somewhere from here till here, this can be considered to be the center of the graph. Now the reason being, if we look at the area that is being put under this graph and the area that is under this portion of the graph, both are more or less similar. Approximately we can say they are similar. That is why our central tendency would lie at the middle of our graph or our data set. So for example, in this situation, somewhere here our median would be lying, somewhere here our mean would be lying, and this, since this is the portion with the highest frequency, this would be our mode. So these three parameters basically would help us to define as to what exactly that data set is trying to tell us. Now let us assume, if now the question that would majorly arise here is that can all these three metrics be equal? Yes, they can be. Let us assume if a graph is made in this manner, which is more or less symmetrical. If I draw a line at the center of this graph, it is symmetrical on both sides. That means here the mode, median and mean would be same, and the mode, median, mean that we are referring to is the class value here. This value here would be our mode or median or mean. In this example, this value would become our mean, this value would become our median, and this would become our mode. So basically the value which is in the x-axis becomes our central tendency value. Now let's study, or let's understand what data set might look like, or how data can be represented, or how data can be given to you in the question. So there are two types in which data can be represented. First being the grouped and the second one being ungrouped data. For grouped data, generally there is a interval of class given. For example, if we were to design a table of this data set, class is here, frequency is here. Group data means where there are a number of values of class that are equivalent to the same value of the frequency. For example, we can say that class can range from 0 to 10 and the frequency here is 5, let's say. Then it can be from 11 to 20 and our frequency would become, let's say, 7. 21 to 30, it's 1. It's 31 to 40, it's 70. or anything. This way the intervals in class work. Sorry, this needs to be 1 so that the intervals in class remain same for all different frequencies that we are talking about. So this basically here is a grouped data, and whenever we are solving questions or doing JEE Mains previous year questions, you will see that there will be range of class given. However, we will convert this into a single value, which we term it as xi, and this would be the mean or the average of the class interval that has been given. For example, here the average we can say it's 5. Here the average would be 15, then it would be 25, then it would be 35, and so on. Again, this is also a portion of x, and xi is basically a single value to represent class, and frequencies are y-axis. So this is how grouped data looks like. And ungrouped data is very simple, where there will be one value corresponding to each and every value in y. So here x and frequency, here the x would be 2, let's say we get frequency 5, 3 we get 7, 4 we get 25 we get 1. So there will be just one value which corresponds to an output. And however, in class we had studied that there are, here in this example, there are 10 inputs which are resulting to the same value of frequency. That means if we were to draw the graph of a group data, it would be in the form of a histogram, which would look like this, somewhat like this. The graphs of group data look somewhat like this. And then what we do is, to make our calculations simpler, we just take the top middle part of each and every histogram and we join them to make a curve that we want. For group data, it is very simple. You will have a specific value for a specific class that you input, and from there you can make a curvature. So this is how the graph of group data and ungrouped data differs. This thing will be necessary for you to understand mean, median, mode, and again when you study dispersion functions as well, which are variance and standard deviation. So now let's start with the first tendency, central tendency, which is a very important part, mean. Again, mean is nothing but the average of all the data that has been provided to you. So for example, let's say our graph is somewhat in this way. This goes up to infinity. Again, a never ending graph. So our mean would be somewhere here. Now why is that so? Because this is the average value of the entire data set here. There are values which are higher than this, and there are values which are lower than this. So both the values, we need to take the average of those values and we will get the mean. That is how mean is generally calculated. For example, let's say a data set is given to you. Let me take the best and most layman example for you to understand. Let's say in a class of students, 10 students, height, measurements are as follows. Let's say it's 30, 75, 82, 57, 90, 102, 47, 91, and so on up till 10 students. And now if I was to ask you what is the average height of this particular class, then what you would do is you would add up all the heights of all the students and then divide it by the number of students that are present in that class. So that is how average is calculated. Similarly, the same thing you will be doing it for mean. The only difference here is that the data set would be very large and it can come in terms of grouped data as well. So how are we going to calculate for that? We will look in the next slides. So first the very easy part, mean for ungrouped data, where the data set, where there is just one value corresponding to one input. So ungrouped data basically means one input for one output. This is what ungrouped data means. So here again, this is the way of representing. I hope you all remember this. We had studied this in sequence and series. A notation to represent summation of anything. So this is basically summation I is equals to 1 up till n xi. So this can be written as x1 plus x2 plus x3 plus up till xn divided by the total number of data that we have. So this is how we calculate mean. And yes, again, this is known as the frequency, and we represent it by x. Now for grouped data, as I had showed you in the beginning of this chapter, how grouped data would look like. There would be class where ranges would be given, and there would be frequency. Let's say it's 0 to 10, it's 10 to 15, 15 to 20, and so on. And there are corresponding frequencies given according to their respective classes. Now how are you going to calculate the mean for this? It would be sigma fi xi upon sigma fi. Now for here, you can definitely calculate the value of xi, which would be the middle term or the average of the class interval. You will get xi from there, and then what you will do is, this is again represented as f, you have to calculate fi into xi. You will multiply the corresponding terms of frequency and the mean class that you've found out. You will multiply those, you will get frequencies. You will have to sum all the frequencies, and then at the end you have to sum all the frequencies that has been given to you as well. And from there, using this formula, you can find out what the mean of this entire data set would be. So that is how you calculate mean of a grouped data. Let me take an example to show you how a data set of mean where grouped data has been given, how can you solve those questions. So let me write the question down for you. Let's say the class has been given. It has already provided to you in the terms of xi, which is 5, 6, 7, 8. Let's say this is a class, the x values that has been directly provided to you. And then frequency has also been provided to you in the question. So this is basically a grouped data. 18, 20, 30, 15, 8 and 7. So now you were to find out the mean of this entire data set. So how are you going to do that? So you remember the formula of mean to be sigma fi xi upon sigma fi. Here you have been provided with f and you have been provided with x as well. So now the best way and the most easiest way where you can avoid any mistakes happening in the calculation is to draw a table and then solve it in a very systematic manner. In that way, you will avoid any mistakes that are happening in your question. So let us write it down one by one. Here xi has been given. We can write it as 5, 6, 7, 8, 9, 10, 11. Fi corresponding to the value of xi, f has also been provided, the frequency, which is 18, 20, 30, 15, 8 and 7. Now you try to find out xi into fi for each corresponding term that is present in this table. So 5 into 10 you will get 50, 18 into 6 you would get 108, 20 into 7 you would get 140, 240, 135, 80 and 77. So now you've received all the values that belong to xi fi. So again, this can also be written as fi xi, it doesn't matter since it is multiplication. So what does this formula basically indicate? This indicates that f1 x1 plus f2 x2 plus f3 x3 and up till whatever number the data set has been provided, and this is f1 plus f2 plus f3 plus and so on. So you know this is the first term, this is the second term, third, fourth, fifth, sixth and seventh. So there's 7 numbers that has been provided to you. And xi fi, again the sum of all the value of xi fi. Now you need to sum all these values, you would get certain value, and then you can sum all the values of fi and you would get certain value. Dividing those would give you the mean. So that is how mean of grouped data is generally calculated. If it is ungrouped data, then that is not a very big problem for you to calculate. There will be just a single access data set provided to you, and you can simply just add them all up, divided by the number of elements that is there, you will get the answer. Now let's look at another way of finding mean. This is by using the formula of assumed mean. So again, here A is the assumed mean. In the given data set, you assume a number. You assume a number to be mean, and then you try to calculate the mean that is for the data set. Here A is the assumed mean, di. Now what is di here? F is, I hope, nothing new to you. Instead of xi, here it is di. Now what is di? Di is xi minus a, where a is the assumed mean and xi is the values of the class that has been provided to you. So this is a different method of calculating mean. Again, this gives out us a very approximated mean. You might not get the exact value of mean by using this formula. However, sometimes JEE asks that give me the answer by using assumed mean formula, and they give you specifications as to how you can assume the number to be. So let's look at a question, an example to understand more. Let's take the same example so that it becomes easy for you to understand. The xi has been provided to you in the question. Fi has also been provided. So xi is 5, 6, 7, 8, and let's say xi is 10, 18, 20, 30, 15, 8, 7. Now this data set has been provided to you. So how, and you were to find out the mean which is assumed. So basically you are finding the assumed mean from this. So what value are you going to assume in this data set? So first, again, the basic and the most important thing is to write down what the formula is for mean, which is a plus sigma fi di upon sigma fi. So you have fi here, you need to calculate di and you need to assume an a as well. So first let's make a table. Again, doing the same thing, making the table would make your calculations easier, and you would avoid any mistakes that can happen during calculations. 5, 6, 7, 8, 9, 10, 11, 10, 18, 20, 30, 15, 8, 7. Now from here you can calculate di. which is xi minus a. Now a is our assumed number, assumption. Now what is the number that we are going to assume here? A is basically a number which you take from the x class, from the x axis only. So from here only you have to assume a number. Now how are you going to assume the number? You can see that there are 7 data points given in this data set. So from here you know that the middle term would again be 8, obviously. Out of 7, 3 this side, 3 on the other side, 8 would remain in the middle, so it is our middle term. So we can assume this to be our a value. So a can be assumed to be 8. Now the question that might arise in your mind is that what if an even number of data points would have been given? Let's say this would have been n is equals to 6. Then there would be 2 middle values. Now which one are you going to choose out of those 2 middle values? Now according to the formula, it is your wish, whichever value you can choose out of those 2. Since during the formula of mean you are adding this value, and here while calculating di you are subtracting that value, so it wouldn't make any difference here. So you can choose any of the 2 middle values which you get if n is an even number, the number of data points is even, and try to choose the number in such a way so that your subtraction becomes very easy for you, because you have to subtract xi here. So a is 8, we know a is equal to 8, so xi minus 8. So we will do this for each and every corresponding value of x. 5 minus 8 would give us minus 3, minus 2, minus 1, 0. This would give us 1, 2 and 3. So we've got our di. Now we can find out fi into di. Similarly, in the same way that we had done for fi into xi, we can do this minus 30, minus 36 and so on. This is the way you can calculate fi di, and then you can take the cumulative frequency, which is the sum of all the frequencies and the sum of fi di, and then you can use this formula to get your assumed mean. This is known as your assumed mean, where you have to assume a number from the class and then try to solve the question. Now let's look at median. That was all for mean. There wasn't a lot of things for you to remember, just a few formulas. Now for median. Now what is median? Median is basically the middle value of a data set. If let's say you are given 7 data points in a set, so what will be the middle value? Of course the 4th term would be the middle value, right? So that is how median is calculated. Now if I were to represent this in a graph and explain it to you, let's say this is our graph that is given. Again, this goes up to infinity. This is generally a standard graph which is used to explain central tendency. That is why I'm continuously using this graph. You can find out mean, median, mode on any graph, on any data set that has been provided to you. So the median here would somewhere be approximately here. Now this term here, this line indicates that the entire data set has been divided into 2 equal halves. That means the area of this portion would be equal to the area of this portion. Let's say the area here was 0.5, then area here also would be 0.5, which together would make it 1. Whatever type of graph is given, let's say a symmetrical graph is also given. So we had learned that the median would be at the center of this graph. You can see that both sides the area is same. So this is how median is calculated. And let's say if you are given a data set along where x1, x2, x3, x4 ungrouped data has been provided to you, to find out the median, it will again always be the middle value of the data set. Now what would happen if here n is equal to even? When n was equal to odd, it was easy for you to find the middle term. Now when n is equal to even, now how will you find out the median? Now for mean, I hope you all remember while calculating assumed mean, if we had been provided with an even number of data set, we were able to easily assume our mean by taking any of the middle values. Now for median, this thing doesn't work. There is a specific formula which we need to remember, and through that you will be able to calculate the median out of those two values. So let's look at that. Let's say an ungrouped data has been provided to you. So the median would be n plus 1 by 2th observation. Of course, I hope you all understand how we get this value. Let's say there are n is equal to 7. So we had learned that the median would be the fourth term would become our median, right? So if we try to use this formula here, 7 plus 1 by 2 would give us 4, which is our fourth observation. Again, median is not 4 here. Median is the fourth observation. In that data set, what is the fourth number? Corresponding frequency that has been provided to you, that will be our median. Now when even number of observations are given, then it would be n by 2th observation. Let me write it down here in a clear way so that you can understand. N by 2th observation plus n by 2 plus 1th observation upon 2. This would become our median. So let's say in a data set of 5, 6, 7, 8. Let's say these 4 are our data set where n is equal to 4. So to find out the median of this, we would do n is 4. So 4 by 2 would be 2th observation plus 3rd observation. Again, this would become 2nd observation, 3rd observation upon 2. So what is our 2nd observation, which is 6, 3rd is 7, 13 by 2. This would be our median. That is how median for even numbers is calculated. Now what if grouped data is given? So let me draw the class and frequency here so that you can understand this. Again, for group data also, you have to find out the middle value, which would become our median, and frequency has been given to you. Let's say this is 1 to 10, 11 to 20, 21 to 30, 31 to 40, 41 to 50. Let's take 5 classes here. Frequency is 5, 10, 15, 0, and let's say 100. So now how are you going to find out the median for this? There is a specific formula that you need to remember, an important formula. There has been a few times JEE has asked questions related to this formula. So you need to remember this formula, L. Now I'll explain to you what the exact terms are given here are. So whenever you calculate group data, there is one new thing that you have to calculate here now, which is cumulative frequency. Cumulative frequency. Now how is this calculated? It is basically the sum of all the frequencies preceding that class. For example, for the first, let me draw lines here so that it becomes easier for you to understand. Now for the first data point, the cumulative frequency would be 5. For the next one, it would become 10, and the previous one, which makes it 15. Now for the third one, it is 15 plus 15. This would make it 30. So we are basically adding these two numbers. These two numbers are getting added. 0 plus 30 would give us 30, and this would give us 130. So this is our cumulative frequency. And this is represented by capital F. And frequency is represented by small f. So here now in this formula, we see h is our class width, which is 10. The interval, basically it is asking what is the size of the interval. So it is 10 here. F is frequency of median class. Now what is the median class going to be? 1, 2, 3, 4, 5. Again, there are 5 here. So the median class would become this one. The middle one would become our median class. This we consider as median class. This is not our median. This is our median class. So from here, you can take down the value of f, which is 15. So if we were to apply this formula, it would become capital F is 130. We just calculated that. F, median class frequency, which is 15, and h is our interval size, which is 10. Now let's look at n by 2. N is total number of frequencies. So 1, 2, 3, 4, 5, you have 5, which makes it 5 by 2. and we have lower boundary of the median class. What is our lower boundary? 21. The lower limit of our median class. So this is how median of grouped data is calculated. I hope you've understood what each variable here corresponds to. Now let's say if in this question you were given 6 class intervals, then how would you find out which one is the median class? You would have to find out which are the first 2 middle classes. Let's say if a data set of 6 class intervals is provided to you, these 2 are middle one. So from here you can choose any one of the middle values to be your median class, and from there you can calculate the median and you will get the answer. So that was all about median. Now let's look at mode. Now mode is a value that appears the most in a data set. Now this is calculated by looking at the table of frequency. Now again, if I were to explain this using a graph, again taking our standard graph which goes up to infinity, class here, frequency here, this, you can see that at this value of x, the frequency seems to be the most. The value of this graph is maximum at this frequency, so this becomes our mode. That is how mode is calculated. So for example, if in an ungrouped data, a lot of numbers has been provided to you and there are corresponding frequencies provided to you, so the one with the maximum frequency would become your mode. Again, the mode is simply the value that occurs most frequently in a data set. For example, 2, 7, 2, 8, 10, 2, 11, 11, 15, 100, 2. This is a data set that has been provided to you. So what would be the mode here? 2. 2 would become our mode, since 2 seems to appear the maximum number of times. And what would be the formula to calculate our grouped data mode? This is the formula. Again, class has been provided to you, frequency has been provided to you. Now from here you will again use this formula to calculate mode, where L is the lower boundary of modal class. Now there would be classes given and there would be certain frequencies given for each class. Now you have to find out which frequency is maximum here. The maximum frequency, let us assume if this was supposed to be our maximum frequency class, so this would become our modal class. And now substituting the values, lower boundary of modal class, of course the lower limit. F1 is the frequency of the modal class. F0, it is the frequency of class preceding the modal class. That means the one that is coming before. Preceding means before. Frequency of class succeeding, F2. So this would be the after. Just immediate after. One step forward, what is the frequency of that class? And H is our class width. Again, it is the range up to which class interval has been provided. So that is how you calculate H. And so this is the formula to calculate mode. Again, an important formula for you to remember. Now there is a certain relationship, of course, since all these three are central tendencies. So there would be existing a relationship between all these three. And this is the formula. There was a scientist named Pearson who found out this relation. Mode is equal to 3 median into minus 2 mean. So generally we represent mode by writing mode, simply mode. There is no notation to representing mode. Median is generally represented by capital M and mean is represented by mu or X bar. These are the two notations of mean. So you need to remember this thing. So mode is equal to 3m minus 2 mu. You need to remember this formula. Sometimes JEE asks questions about the relationship of mean, median and mode.